what happens when you try to design a safer, faster route to Sydney Airport through one of the city's most constrained transport corridors without impacting the traffic, the planes or the trains. In this episode, we dive into the Sydney Gateway project, the new $2.6 billion toll-free connection linking the St. Peter's interchange to Sydney's domestic and international terminals, and unpack how BG&E's bridge team delivered the detailed design for 19 bridges on a live brownfield site. You'll hear how the team pushed the boundaries of bridge design, including an Australian first incrementally launched network arc bridge that sweeps around Airport Drive near the end of the north-south main runway, cutting steel tonnage, simplifying construction, and reshaping the airport's skyline in the process. And we'll talk about what it really means to design in such a complex environment, from tight geometry and staging around existing roads to ambitious sustainability outcomes, and how it all translates into thousands of people now moving more effortlessly through one of Sydney's busiest gateways every day. Hello, everyone, and welcome to another episode of the Inside BG&E podcast. Today, we have our bridge team, and we're going to talk about the Sydney Gateway. Would you guys please introduce yourselves and tell us a little bit about your role here at BG&E?
My name's Joe Turner. I'm the New South Wales Bridge Lead at BG&E. I was the Structures Lead on the Sydney Gateway project.
Daniel Fryirs, Associate with the Sydney Bridge team. I was the Bridge Lead on SB21, which is the twin bridges over Alexandra Canal and Port Botany Rail Corridor.
Yeah, hey, I'm Luke Wetherstone. I'm Senior Bridge Engineer with BG&E. For the Gateway project, I was working on the viaduct structure and was package lead on one of the smaller bridges.
For the people who haven't driven this yet, what is the Sydney Gateway and why was it needed?
The Sydney Gateway project was, I think, been in the working since about 2012, 2014, around that time, and fundamentally acts as almost like a large three-way roundabout feeding traffic to and from St. Peter's Interchange, which brings traffic out of WestConnex and feeds it to and from the international and domestic airport. It also has a international to domestic road to it as well, and it involves Sydney Airport giving up a bunch of their land in exchange for some land to make the project a reality. The project is mostly situated over the old Tempe Tip to the north of the main runway, but then ties into, as I said, St. Peter's Interchange and into the domestic and international terminal. That's probably it in about a nutshell.
Yeah, I guess just to add to that is, I guess the main benefits of it are you can essentially leave either the domestic or international airport and get just about anywhere in Sydney without a single set of traffic lights. Yeah, cutting down freight and domestic transport.
All right. And in comparison to any other type of bridge projects, is there anything that makes it stand out or differentiate from other projects?
The standout is likely just the constraints in terms of very brownfield environment. You've got a lot of various stakeholders involved, high profile location at the airport, and you've got rail authorities, water authorities, transport for New South Wales and AITC as well as some of the key stakeholders. So yeah, just certainly that high profile location and complexities in terms of key constraints of like physical constraints of where you can actually fit these structures on the road alignment.
Yeah. We don't want to talk too much about the constraints because that's one of the questions that I have for you guys. But how did we get involved in a project like this?
Yeah, so we were engaged directly through the contractors joint venture of John Holland, Seymour White, through some great work of not only our bridge team, but Graham Reid and Matt Ing banging on doors and requesting coffee meetings with some of the senior execs of those two big construction companies. Got us a seat at the table and we managed to grab hold of all of the bridge works on the project. There are about 19 bridges, depending on how you want to count them. So we undertook a tender design for John Holland, Seymour White, 2019, much bigger than anything we've ever undertaken. We had to upsize our team 20-30% for the tender, and we did a good job. You know, we got a good design in. It was competitive, gave Transport New South Wales a feeling that like they were in a safe set of hands, and the John Holland Seymour White design management team, led by Michael Merricks Evans, also did a great job of giving us the confidence as well to be bold and innovate and do things differently. No one bridge was straight, square. Everything was curved and skewed and non-standard. And he gave us sort of the confidence to, with a blank canvas, draw and design something bold. And that our bridge team did a good job of that, and the rest is history. Here we are.
I think as well, Joe, like the fact that our team was really quite young on Gateway probably helped that as well. Like we weren't really too bound by preconceived notions of how things should be done, and so it meant we could challenge things a little bit more.
Yeah, I guess ultimately, as we've kind of touched on, the complexity of the project led to pretty constrained environments that required a bit of outside the box thinking. Not one bridge was sort of a copy paste of the next. Everyone had a fairly unique challenge in terms of be that vertical alignment, horizontal alignment, or the structural form. We did rely quite heavily on steel design for this project in terms of being able to try and slim down a lot of the bridge decks and make sure that we could fit within the vertical constraints of both the obstacle limitation service above and then also the various roads, rail infrastructure underneath. In terms of the innovations, a lot were involved in terms of the construction methodologies as well. So large reliance on self-propelled modular transport to get some of these very large structures into place, which leads to a large degree of temporary works associated with those operations. Twin arch bridges, one of the first times you would have ever seen a bridge like that launched across a canal. In terms of the limitations of the canal itself, we weren't permitted to have any either temporary or permanent supports within the canal, just to do with environmental concerns of trying to dig up contaminants within the base of the canal. So everything had to be either lifted over the top or launched over the top or in some way or form placed between the two banks. In terms of some of the key innovations, even with the Super Ts, what you'd consider more simple structures, very few of those were actually managed to be just simply supported. We required continuity across piers or between adjacent structures to make sure we could get the structural depth as thin as possible, once again to meet the road alignment and vertical constraints.
Yeah, and I guess talking to the viaduct structure, which runs along Qantas Drive, like as Dan mentioned before, huge constructability constraints, which drove us to pursue precast headstocks. Again, we're talking like 5 metre working width between live traffic that's being maintained for basically the entire duration of the project. Airport's still operational. And then the viaduct does basically a 90-degree turn at O'Riordan Street as it goes in the Sir Reginald Ansett Drive. Yeah, I think this is the first time I've seen a steel to concrete integral connection, and that was quite innovative and challenging. Not only the permanent work or the final configuration design of that, but also the staging of you've got these steel beams that are effectively turning 90 degrees around a curve, and how do you hold them down in the temporary case before you get that integral connection formed was really challenging, and the team did a lot of good work there.
So you guys said that it was a young team, and that was sort of like one of the advantages in terms of, I guess, approaching solutions and stuff like that. Was it also sort of like challenging for you guys as, was it something that you had done before?
I think we had enough grey hairs around that we were able to bounce ideas off them. Just the core of the team was like, I don't think I'd be wrong, guys, jump in if I am, but the core of the team was really quite young and keen, but that doesn't mean we were inexperienced. And while we might not have done these particular structures before, I think there were very few people in the country that had done a lot of these sort of structures before. There was just there were 19 bridges, as Joe said before, like there was a real variety of structure type, and that was, part of what made the project so interesting for us. But yeah, as I said, I don't think the team was inexperienced, and it meant through our previous experience we could sort of use first principles thinking to figure things out.
Yeah, I guess ultimately having a team that was eager to challenge the norms and try different things with that, with the grey hairs around to be able to bounce those ideas off, but at the core of it, just being willing to try new things.
Can you talk us through the twin network arch bridges on Airport Drive? What exactly are they, and why did you guys choose that solution in that area?
Yeah, there was very, very low headroom, or structural depth, which is the depth between the road alignment and whatever the constraints are below. So for a 100-metre span bridge, typically you want to try and fit the structure below the road alignment. However, we just didn't have that room. So then you need to look at what type of through structures, where the structure sits above or beside the road alignment. And that road alignment really unlocked a whole lot of other benefits for the program. We were able to build both those bridges with traffic on Airport Drive live the whole time. So very early on in the piece, Michael Marix-Evans and the design team came to me and said, we're going to have to try and come up with something that we can fit a bridge deck within about a metre, which, for a 100-metre span bridge is nearly unheard of. So to get that road alignment touched down on the other side without, 7 or 8 metres of fill was going to unlock 6 to 8 months of program. So the bridge design team set off saying, right, what can we actually put in there? And very quickly, one of the only bridge types that was possible was a tied arch. And how that evolved was then that tied arch then became a network arch. There were a bunch of guys on the job, Mithan Mohan, Bruce Gibbons, and Mustafa Kakmak, all basically came up with this idea that we were going to have a unbraced 100-metre long, 25-metre wide, 60-degree skew network arch, which has never been done before in New South Wales, and have a very, very thin deck which sat in that profile. Had to be above the 100-year flood and had to obviously sit underneath the road alignment. Then the construction team said, Joe, I need your team to work out how to incrementally launch this bridge. And, if our job wasn't hard enough, that's how we were going to build it. Again, as Dan said, never been done before in New South Wales or Australia. I think we could only find, and our launching partner, Fresnay, could only find an incrementally launched square network arch once in the Northern Hemisphere. So to be able to design that with a team that has never done this before and then sell that to Transport New South Wales and give them the assurance that, they're in a safe set of hands, that then sort of becomes my job of showing to them that, what we've got is the right solution. It's safe. It ticks all the boxes. You're not going to have a problem with this halfway through the design and halfway through the service life of the bridge. So that's the beauty of these jobs. You can't use super Ts, you can't use planks. Conventional steel bridges don't work. You've got to be bold and innovate and come up with something. And you put all the bits that you do know, all the little building blocks from those simple bridges you learn around constructability, steel design, maintenance, incrementally launching of concrete bridges. You put all that together and you can come up with something that's never been done before. But fundamentally, it's built with building blocks and lessons learned that you can pull from all these other projects. And so that's what innovation really was for that bridge. There's a lot of sleepless nights, not because we were worried about the design, but because we were excited and trying to solve some of those challenges as we went was exciting. During COVID, all while
to line up.
Yeah, that's right. I was in the garage. I had the laptop set up in the garage because we had a 1-bedroom apartment with a newborn. So I was in the garage on Teams trying to explain to Transport New South Wales that we're going to launch this massive bridge downhill 6%. That was fun.
I guess on COVID, Joe, I think that was one of the real achievements of the project, because we went from this really tight-knit design team where the contractor, the IC, the designers, everyone that was involved in that project was physically located on site at Mascot in this design office, really working close together. And then all of a sudden, boom, everyone's working remotely for 3-4 months, right in the middle of our STDs or something, wasn't it?
That's right. Yeah. Yeah. And basically the only people that were allowed to go to work were doctors, the fire brigade, and Sydney Gateway. Critical jobs. So yeah, you're right, Luke. It was just another curveball.
So how did you incrementally launch? If I get the numbers wrong, please correct me. But a 100-meter, 2,000-ton arch bridge. How do you do that for people that aren't that familiar with bridge design?
It wasn't really incrementally launched. Incrementally launched is more used.
Sorry.
For that's okay. That's because that's what when we market that way as well. It was almost like abseiling. It wasn't build a bit, push it, build a bit more, push it. It was a downhill 6% grade, which the launching friction. Yourself. Yeah, that's right. It was not pushing. We were sort of lowering it down the hill. Fresnay did a fantastic job of developing not only the biggest, widest launch nose in the country, 70 meters long, but developed a series of other temporary works devices, mainly the launching bearings, which were the size of a small car. They did a fantastic job of that, and they brought a lot of experience to the table as well. BG&E, we've probably launched somewhere between 25 and 35 concrete bridges. I've lost count, but a network arch, they've probably pushed a few more steel bridges than we have. So they brought a lot of experience to the table, and that together with our guys did a very good job of coming up with all the issues beforehand and solving them. But yeah, in a nutshell, it was just lowering it down the hill across the canal. Yeah, it turned out to be quite simple. Everyone thinks launching, wow, complex, expensive. It doesn't have to be that way. If you simplify things, you can make it quite easy and cost effective and safe. The rest is all trade secrets, Laura. I remember one of the big exercises was rotating the arch up for the first time. One of the funny little facts that I find it funny was the arch was built on its side, flat packed, right in front of the IKEA factory in Tempe. And so we had to then, the first operation was to tilt the arch up from its side vertically. And that in itself was an amazing piece of temporary works or piece of construction engineering. But think about it it was like a door. We had to bolt it down to the ground on these massive hinges called rotating brackets that had clamped to the bottom chord. And we knew that it was quite floppy out of plane, in the weak direction. It's obviously very, very strong in the stiff direction. So as we were, tilting it up from its side, we saw it bend as we predicted, and we weren't sure how much of that pre-bend or that bend was going to straighten out. I had sort of in my mind maybe it wouldn't all straighten out, and that's what sort of evolved as well. As we tipped it up vertically, some of that bend that it underwent while it was on its side kind of got locked in and clamped in from those rotating brackets. And that meant that once the arch was vertical, a little locking pin that was designed to basically hold the arch vertically, the two holes didn't align because of that curvature. On the night, on the fly, we had two or three of the designers out there. Had the day off the day before, so they were nice and charged and fresh for that night shift. We probably had too many McChicken nuggets and coffees, but that's the story for another day. And fundamentally, we had to work out, well, actually, if it's so floppy out of plane, how do we straighten it up and get it straight? So this locking pin, I went back in, and I think some of the guys were in the back of the hatchback with some chicken nuggets on strand 7, trying to work out how much force we would need to pull it back straight. And like anything in engineering, if there's something negative, often there's a hidden positive right next to it. And because we realized, well, if it's so floppy out of plane, maybe it wouldn't take much load to pull it back straight. And that's basically what happened. We worked out it only needed like 4 or 5 ton pull on one end, and that came from the back of one of the car in the car park. 2 of the guys on strand 7 running some models onto the phone to me, and then straight to the guys on site. The arch got pulled back straight, and the locking pins went in with, I think it was like 45 or an hour to spare before the crane had to be down out of the OLS so they could open the main runway. So that was one of those moments where the heart was going, for sure. I was wishing I didn't have too many McDonald's coffees, but yeah, that was certainly one of those moments where you look back at it and you feel really proud of the team that they had done all the ground and all the homework and everything was there ready to go. And usually with these jobs where you are designing for the first time, you're the one that discovers all the curveballs and all of the issues that pop up along the way. And it's about how you adapt to those on the night or on the day when time is of the essence, and we make sure that we never rush things, and we were checking our calcs, even if they're a small little quick check. We were making sure that we were sort of making the right decision and no one was under any time pressure. And yeah, the team did a fantastic job.
Just to expand on that, I guess just the reason behind ultimately why we were undertaking this arch rotation is just to do with the proximity of the airport. So John Holland and Seymour White essentially took the idea that they didn't want to be working, they wanted to reduce the amount of working at heights. So if the arch itself needed to be delivered to site in, I think it was 6 pieces. And if they were to install that vertically, they were up in the air about 20 odd meters trying to do pretty significant welding operations, which was just too much of a safety and design risk. So they opted to build the thing horizontal, and then it's up to us to work out how you actually, working with the construction team, how you're actually going to bring it up to the right location. So yeah, just working with both our construction partners to try and develop that solution and make sure that it could happen in a safe and efficient method.
You know, the biggest challenges, I mean, you guys were doing this live in an airport. Any other constraints that you guys want to talk about?
You've got utilities running everywhere. You don't know what you're going to dig up when you start putting piles in the ground necessarily. You've got, all the stuff that comes with the airport as well, all the infrastructure and traffic and whatnot.
Did you have to, did any design standards or specifications need to be adapted for the conditions of the site?
Yeah, mostly for the network arch. AS5100 really cover stayed structures, so we had to work with Transport for New South Wales and develop a bespoke design standard and an SWTC that was going to pull the best parts of different codes into what we wanted as a team, including Transport. So we used the PTI guide, some parts of AASHTO and the Eurocode, developed a good sound set of design requirements for the arch.
And are these conversations when you face these in a design, are these easy conversations to have with the client, or do you have to?
Yeah. I mean, look, typically on most bridge projects, they'll set the rule book. They'll tell you what they want, within an SWTC or a deed. And they did that in a way. They said, look, if you're going to, produce a network arch, here's what we want you to do. And we worked with them to refine that. And, some of those requirements weren't giving them the value for money they thought they were getting, and we added some more in where we felt that was a bit thin. So it was good to work with their technical department, their bridge branch, like that, because you don't often get to work with them, collaboratively, almost like an alliance. And it's good to see those guys work with industry just to get the right outcome for the public.
On the constraints, it might just be worth unpacking the OLS a little bit more, the obstacle limitations surface, which was a key criteria for, I think, almost every bridge. There might have been one or two that wasn't too much of a constraint, but it's basically the surface which you cannot have any construction equipment or anything really pierce it, because you may then interfere with airport operations. Joe, you probably know this number. What was the lowest height OLS from deck surface level?
Yeah, look, I think SB 4142 was probably the one where my eyebrows were raised the most. The top of the trucks on top of that bridge were less than 50 mils below the OLS. Yeah, we used to joke. We used to joke that you had to walk around on one of these bridge sites with your head ducked down, so A380 didn't land on your head. But it was just crazy, crazy tight, the amount of vertical space that you had to put a bridge. But yeah, look, I think some of them SB 4142 and SB 2161. All of those bridges were only just had enough room to fit the vehicle on the bridge before it's poking into the OLS.
Yeah. And so that constraint had huge construction implications, because it meant piling rigs, nothing can pierce that during those operations. There's only a very small window every night where you're allowed to breach that OLS.
It's not every night as well. The amount of rules that you need to go to actually get permission to undertake those works within the OLS, even after curfew, was pretty substantial. So yeah, the amount of pre-work that goes into the operations, say with the installation of SB21, with the SPMT, while the SPMT was driving over the existing Nigel Love Bridge, even there, because that's right at the northern end of the runway, the bridge itself, the girders were sticking up within the OLS. And so it had to be over Nigel Love Bridge and down the canal away from the OLS within, I think it was about a 4 or 5 hour window they had.
Yeah, pretty wild.
Crazy. And you just drive through and you don't realize how much it goes into this type of projects. It's a bit interesting. Yeah, we take it for granted, the brains behind it. You're
talking about trying to move 300 ton worth of steel. You're only moving it, a few hundred meters, but still it's a significant operation to get that across the line.
What was your favorite part about working in a project like this? I'm guessing professionally, a lot of rewarding feelings.
I think it was the proximity of just the diverse team we had, right? In terms of both the design side and construction side, how integrated the team was to be able to develop the solutions. The only way we could get across the line in terms of some of these construction methodologies was that we're working directly hand in hand with our construction partners to develop the solutions and make sure that they could be built in a safe and efficient manner.
Yeah, I mean, this sort of project is why you get into engineering. It's to deliver like really high quality, big, fantastic projects. Like as Dan said, you're working tightly with all these different stakeholders. You're working on like state of the art designs, some stuff that has like never been done before, or at least never been done in a certain way. And to be a part of that, and then to be part of that journey and see it come to life, and in hindsight to see it come to life so successfully as well without too many major hiccups, has been incredibly rewarding.
One of my favorite parts is sitting at the Heineken bar at International Airport, looking out, seeing SB21. A lot of attention gets put on SB51, but 21 has more deck area than all the other bridges combined. I don't know if that's actually that true, but graphically it looks it.
What is FB21?
Dan's Bridge. It's very, very long, very wide. It's probably got the most constraints. It's got ARTC, Sydney Water, Sydney Airport. It's got is it Boral? It's just got everything. Yard. Whoever decided to put a bridge there is crazy. The other beautiful bridge that doesn't get a lot of shout out is the Stage 3 viaduct into the domestic terminal. Yeah, that was Luke's baby.
Me and Justin Jameson.
Luke finished that and then needed a bit of extra homework, so he then took on a couple of other Super T bridges.
Do you want to mention sort of like the key ideas behind that, or anything else that you want to mention about your baby?
It was this really interesting, complex geometry where we're trying to cross over many major roads going into the airport, and we're doing it in a really we're trying to do it in basically the most efficient way possible. So most of the spans are simply supported Super T, but we also have a simply supported steel span. We've got an integral steel to concrete connection. We've got some slightly different depths, but we really, like Justin and I really worked a lot and with the contractor on getting it to look as seamless as possible. I think there was some inspiration taken from like the serpents and just having this nice curvy structure that flows in there. So the geometry itself was probably outside of the fact that we were constructing in between Qantas Drive. The geometry of the structure was really a big challenge and constraint, and getting, as Joe mentioned before, getting Super Ts to look sexy, because they're typically not considered the most aesthetically appealing bridge type, precast, pre-stressed girder. But yeah, I think we did a good job. And no, what in general, you think Super Ts are beautiful? I mean, I think we can appreciate the efficiency of them as bridge engineers, but perhaps the general public doesn't.
I actually thought they were quite nice.
Well, that's great. Like, everyone has their different opinions on things. I'm just saying, traditionally, SB51 is going to win out on the sexiness appeal for sure, the big network arch bridges. But yeah, the geometry was really a challenge. Everyone's going to remember the screens on the outside of the viaduct, which look fantastic. And that's great, because then they won't see the Super Ts so much. They'll see the screens that have the lights coming from behind, and it looks really fantastic at the end of the day.
What's the biggest lesson learned in this project, personally or professionally, like from your point of view? Not so much technical, but for you as an engineer, what was the lesson that you would pass on to any other bridge engineer?
In terms of lessons learned, I think really just highlighted to me the power of, it's going to sound cliche, but the power of working together in a really tightly integrated team, and just how much you can achieve. Sydney, I'm going to get some of these stats wrong, but Sydney Gateway was one of the biggest projects going on in Australia at the time in terms of the overall value. In terms of bridge design, easily would have been the largest at the time. And it's pretty rare to have 19 bridges in one project, let alone 19 complex bridges. They weren't just, simply supported Super Ts, 19 of them, 19 complex bridges. And yet, because of the team that we had, and we're all working together so closely, whenever there were any sort of coordination issues, you could get up and go and talk to somebody and resolve it. As my understanding is that project was delivered on time, on budget, with very minimal mess and fuss. We just, as a project team, and I'm not just speaking specifically about the design side of things, although definitely that as well, but we just smashed it out of the park. I think that was a range of things, but yeah, really being able to walk through construction methodologies and then have really tight feedback loops on all all of our sort of decisions, where we could discuss something with the contractor, they could throw in their ideas, we could have a little bit of back and forth, and then we'd go away and work on it. But when we go away and work on it, we'd like go to our desk, which is 15 meters away, and work on it. And then, you know, later that afternoon, you've got an answer or an update, and we can like iterate on that. Or if there's a coordination piece, you can go and talk to like the utility designer and see like, okay, what's the latest and greatest survey info you have on this area? Where are the like existing Telstra lines running, and can I move my pile over here or something like that? I think, yeah, just more broadly, like having really tight feedback loops on all that stuff is just really super important to the successful delivery of these projects. And I think that's something that, like, as much of a proponent as I am of like working from home, I think we still aren't as an industry doing it terribly effectively. And not to say it's impossible, but there's more we could do there to bring back more of that collaboration to tighten up those loops a little bit more.
I was going to ask you about that. Sorry, Dan, if you have your answer ready, just give me 1 second. Because you did guys say that you delivered this project in COVID. Like, was that really difficult? Like, the collaboration and, you know, having to just come to see someone on the desk. It was sort of like, oh, should I call them? Like, is it ready? Like, are they free?
Yeah, I mean, like one thing that we did, Justin and I, on the viaduct, because we were working quite closely together, is like we did sort of similar things in the software engineering world, where we had daily stand-ups where every day we'd just be on the phone. There were times where we would call and just work together, if that makes sense.
Yeah.
So we'd just be on the phone working, and we wouldn't necessarily have to talk, but you'd just be on the phone. So then if something comes up, you're just ready to have a chat, and try and remove as much of that friction of sending somebody a message or hitting call on Teams as possible. And I think the contractor really bought into that as well. It probably was a bit more of a shock for them going fully remote than it was for us. Like, most of our work's done in front of a computer, but for them, they do a lot of their work talking and being face to face. So I think it's also a testament to John Holland and Seymour White and the way they were able to jump in and help resolve things.
Absolutely. It would have been really hard for them.
It would also, I know you got your lesson learnt, Dan. I don't know if you feel the same way, Dan, but in hindsight now, 5 years on or something from the bulk of it, you know, we talked about being a young team and whatnot, and it's like, you're a few years older than I am. In hindsight, I look back and I go, shit, that might be the best project I ever work on. And that's a little bit sad in a sense, you know? Like, I don't know if I'll ever work on another project with that many.
It's a truly legacy project. Like, it truly is. Like, as you said earlier, when you were like, this is the reason why people choose engineering. Absolutely. Like, as soon as you talk about, you know, engineering, people are like talking about, look at the bridge. Like, it's that. And for you guys to be part of it in, you know, whatever stage you were in your career, like, it's just one of those ones that you like proud to say, like, put your hand up and be like, yeah, I was part of the delivery of that. Yeah.
Yeah, it's certainly going to be a pretty unforgettable project to be able to look back on as a hallmark of your career and real sort of crowning jewel. But yeah, I guess to my point earlier in terms of the lessons learned, trying to find the simple within the complex, we were dealing with a range of very complex issues, complex constraints, complex methodologies that needed to be resolved. And the key lesson I learned was trying to break that down into digestible and simple components that you can put together to create that. If you try and sort of overanalyze, you end up with you can get paralyzed in terms of that overanalysis and trying to find the optimum solution. But if you can break it down into those simple components, you're able to get to a solution that can satisfy the constraints and that you can also sell back to the client in terms of bring them along the journey.
It's physics, right, Dan?
It's just physics.
What do you hope users and, you know, the city of Sydney remembers when driving or about the Gateway project in years to come?
I mean, I think one of the really nice things about the project, and maybe going back to why Sydney Gateway matters, is like Sydney has, in my opinion, a lot of really nice bridges, but you don't see them as soon as you get off the plane. And so having, like, in particular, SB51, which is the one that stands out like a sore thumb, or like a very well nail-polished thumb.
Perfectly proportioned.
Yeah, perfectly proportioned, yes. Dan, what do you hope people notice?
Like, To sort of counter what Luke was saying, you almost want to hope that they notice nothing, that what we've delivered actually integrates within the local environment, the urban design environment, that the structures, while they're integral with the road alignment, but they ultimately blend in to the background and provide the crossing required, but don't stick out and in an obnoxious way.
No, I think that's a fair point, Dan. Like, for the most part, as bridge engineers, we don't want our structures to stand out. Like, they're there to serve a function. And if people notice something, that's usually not a good sign. It means something's not.
That's crazy.
Not doing what it should.
I would have thought, like, there's a lot of, like, visual or aesthetic to bridges.
There's a lot of visual aesthetics in terms of the solution with a lot of the structures, and in particular the arch and the viaduct, like what Luke mentioned. But predominantly, I guess the urban design intent was to blend in and provide a fairly cohesive look throughout the entire project. So we had 19 very different looking structures, but at the end of the day, if you looked at them as a whole, it's very cohesive and integrated solution that all sort of blend together into a final intersection.
Awesome. There was something that whilst you were talking, Daniel, I actually thought about, but it's gone. Yes, about pedestrians. Were there any sort of like features for pedestrians or cyclists within this, if we want to talk about that too?
Yeah, there's a full ATL, or active transport link, integrated within the solution. It runs along the northern bank from the west, and then crosses over the Alexandra Canal just to the west of Bridge SB21 over a simply supported steel composite span, and then continues along the southern bank towards the east. But yeah, I think it's a 3 metre wide shared user path for that full extent.
Whose baby was that?
The underpass. Yeah, there's quite a number of people involved in that one. So I guess most of the alignment for that ATL was just at grade. So that was handled by the AAJV design team. But there's an underpass underneath the approach to the existing bridge, the Nigel Love Bridge that I mentioned earlier, and that was handled by our colleague Dashika, now part of our Melbourne bridge team. So yeah, that was her baby for a while in terms of that underpass, and then the main crossing over the canal was largely designed by our partners in the buildings team, Xiao Yu. She took a stint over to buildings and gave it a crack, and delivered a fantastic end result.
Thank you so much, guys, for your time.
Thanks for having us.
Yeah, absolutely.
And that's just one piece of the story behind how our people shape the way cities move. Stay tuned for our next episode, where we shift gears from major transport links to crisis moments on site, and sit down with BG&E's emergency response management team to unpack their projects, their approach under pressure, and how they keep critical infrastructure and communities safe when it matters most.